Hey everybody, Harold here. Today I want to talk to you about categorical data type in Polars data frames. We've seen enum for a known number of values. Categorical is for dynamic, open-ended string categories where you don't know all the values up front. You create a category, you can do it a couple ways. You can cast it. So let's import Polars as PL. Here in our collab notebook. I'll add this to the GitHub repository and a link in my description. So I'm going to make a one row data frame, column named task. The three tasks are crush, kill, and destroy. Later, if I wanted to add another task, I could easily add one. Let me just print that out real quick. So task, categorical data, crush, kill, destroy, a 3x1 Polars data frame. In enum, if I did this, it would throw an error because it's already defined. Let's be nice now. Crush, kill, destroy, save. And you can't do that, no error. So if you're not sure how many categories you're going to have, use categorical. If you're sure, use enum. Or you can also declare in the schema like we did with the Laugh Olympics data frame in the window functions videos. So I could say schema equals name, string, team, categorical. Maybe there's another team that's going to join the next Laugh Olympics, so we wanted to keep that open, not make it an enum. Scores and then 32 ratings of float. 64. Here's the DF with the second argument being schema equals schema. Print that DF, and you'll see that team is categorical data type. So I've cast it as a categorical. df.with columns, pl.cast.cast, pl.categorical. I've also used it in a schema and then applied that schema to a data frame. So that's two ways to create a categorical data type. It's not really much you can do with it besides create it, but the really, really important piece of it is why we use it. Um, String columns store the full text of every value for every row. Categorical instead stores each unique string one time. The rows hold a small integer index, typically 5 to 10 times less memory when a column has few unique values relative to its length. You might say low cardinality, million columns, but only four type. You had a million columns, they only had four different values. That's very, very low cardinality. Filters, group bys, and sorts also are faster since they operate on integers under the hood. So it's not looking for Scooby Doobies. It's called Scooby Doobies 1 and it's operating on a 1. Yeah. Really cool way to show you this. I came up with this time and memory saving comparison script. We'll run through it real quick. Import time sys from collections import counter, and then we need NumPy and polars. I'm going to create a list of 1,000,000 random fruits out of the list apples, apple, banana, and cherry. I'm going to create a Python list. So PyList equals list random fruits. I'm going to time it, get the size of it. I'm going to do the same with a NumPy array. Time it, get the size of it. I'm going to do the same with the polar string column, or what you would have in a panda string column also. Time it, get the memory size. Then finally with the categorical from Polars. I think you'll, then we'll print out the type, memory, and count time for each of the four tests. So I think you'll get a kick out of this and see really how powerful this is. So let me run this cell. It'll go fast. Okay, type. Let me blow this up. Python list took 78.67 megabytes of memory and about 0.136 seconds. The NumPy array, that's better. It only took 24 megabytes. It was a little slower at 0.1881. Polar, since it's built on Rust, fast. Even the string type took 5.67 bytes of memory and did it in 7/100ths of a second. Cat only took 4 megabytes in memory and did it in a flat 1/100th of a second. So from a Python list to that, that is huge. And if you're working with millions of rows, it's going to save you a lot of time and memory. So the main points in categorical are you use them when you don't know the number of values at compile time, and they save you a lot of time and memory when you're operating on your database. So I hope you liked this video. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.